What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it with more amazing SAT content. So as I mentioned last week, the College Board just released 2 more practice tests, which is amazing. Practice Test 5 and Practice Test 6. I'd started Practice Test 5 last week, Module 1. That's a separate video. Check it out if you haven't checked it out yet. But now we're on to Module 2. And for those of you guys who are new to the new digital version of the SAT, Module 2 is adaptive, meaning if you do well enough on Module 1, and I'm pretty sure I got everything right on Module 1, but you don't even have to get it perfect. But if you do well enough on Module 1, you're going to advance to the more difficult Module 2. And that's what we're going to do today. And the Module 2s are pretty fun, pretty interesting. That's where we're getting into the really difficult, challenging questions, I'd say, on this new digital version of the SAT. So it's going to be a lot of fun. And for those of you guys who are preparing for this upcoming May SAT or any other SAT in the future, I highly recommend these walkthroughs. I feel like they've been one of the most popular things on this YouTube channel throughout the years. And the reason why is because students learn really, really well from problem walkthroughs, in particular for math on these standardized tests. And what you're going to see today is you're going to see me solving the problems, not just showing you how to do them, but solving them on my feet for the first time in real time. So I'm going to show you how to do this within the time frame legitimately. Okay, I haven't looked at this before, I haven't prepped it, nothing like that. So we're just going to go for the gold. I may make a mistake. Hopefully I won't, but that's the fun of it. We're gonna explore it together. All right, guys. Without further ado, we're gonna jump into this. And you guys have any questions, comments, put them in the chat. I won't be able to check on the fly because I'll be fully focused and dialed in to the test, but I'll definitely get them afterwards. 1100 is that bad on a first try? So when people ask me questions like this, what's a good score, what's a bad score, etc., you have to remember it's relative to, look, this is a baseline, right? 1100 is your baseline score on your first try, and that's your mark. So if you're trying to get into a school, or you're looking for schools that would kind of like have an average, let's say, or an interquartile range that would include 1100, then you're in the zone of where you need to be. But you see, it's relative to where you want to go to school, what you want to achieve, what scholarships you're trying for, etc. But remember, it's just a baseline. It's a jumping off point. And that baseline doesn't necessarily cap anything. If you get a 500 on your first math portion of the SAT, it doesn't mean you're relegated to a 650 max out, like 150 point. It doesn't work like that. There's so many variables that are in the mix. One of the biggest variable is how much time can you devote to preparation and really understand the material correctly. So these are the things to consider. Robert King, what's up? Thank you, my man. I appreciate it. Robert King has been following the journey for a long time, and as you see, I'm still here, still going strong, still doing my thing. So anyways, let's get into it. I'm really excited to see Module 2. I'm going to have a little whiteboard up here that I'm going to go back and forth with, and we're just going to hit it. So here we go, ladies and gentlemen, within the Blue Book app. 3, 2, 1. Oh, yeah. All right, zoom in a little bit. Right triangle's length is 11 and 9. What is the length of this triangle's hypotenuse? Okay, so we're going to do here, its simplest radical form. So that's going to be 9 squared plus 11 squared is equal to c squared. We're going to do this mentally just for fun. That's 81. That's 121 equals c squared. That's 202, right? 202 equals c squared. So to get c, we have to take the square root, and we got it right there. Now, it could have been simplified, they could have, if it could have been simplified, they would have put the simplified version and not this one as well. So it has to be that. Boom, done. Okay, for the linear function graph, xy plane passes through point 7, which equation defines it? All right, so let's get the slope. We're going to stack the coordinates. We got 9, 25. This is how I like to calculate slope. I like to stack the coordinates, and then I subtract down, and I do the difference of the y's. 25 minus 21 is 4. Difference of the x's, 9 minus 7 is 2, and then it's rise over run, 4 over 2. So we know we have a slope of 2. Let's use this cancel out feature here. Oops. So we know that's the wrong slope. That's the wrong slope. Oh, it's right here. Now we're going to double check. Plug in 7. 7 times 2 is 14 plus 7 is 21. Plug in 9. 2 times 9 is 18 plus 7 is 25. Double verify. Boom, done. All right. Number 3. A company that produces socks wants to estimate the percent of socks in a typical week. Random sample of 310 socks during a certain week were inspected. During this, it's estimated 12% of all stocks. Okay, margin of error. So as soon as I see margin of error, I'm going to add it and subtract it. So that means 12%. On the high end, we've got 15.62%. On the low end, we've got 8.38, right? You can use a calculator if you need it. 8.38%. Okay, so this is the acceptable zone based on that margin of error. Based on the estimated the most appropriate conclusion. Okay, so no, makes no sense. It is plausible that between 8.3, look at that, boom, defective. And that's the answer that we want. 12% of all socks were defective. And this is the range. That's what margin of error means. It's plausible. Doesn't mean it has to be plausible in between those. 12%, nope, that's too definitive. It's plausible that, it's more plausible that it's in that zone, that it's more than that. Boom, done. All right, number 4. A truck can haul a maximum weight of 5,630 pounds during one trip. The truck can be used to haul 190-pound piece of equipment, as well as several crates. Some of these crates weigh 25 pounds each. The other ones weigh 62 pounds each. And I'm immediately, okay, I don't know which goes with which yet, but I'm kind of putting it in as I'm reading it. I'm assuming X is with the smaller value. That's usually how it goes. Yep, X. And the number of 62-pound crates, Y. The truck can. So what am I doing? I'm setting it up to get all the weight together. And that's what logically is making sense to me. The total weight that the truck can carry, 190 plus 25 per crate of those ones, 62 plus crate of those. And then they said an inequality, and it can haul a maximum. So this has to be less than or equal to 5,630. There's our inequality. And then looks like what they did is they subtracted 190 from both sides. They isolated the variables. And what is that? 5,440. That's equal to 25x plus 62y. And it's this one. It's a maximum, so it's got to be less than that amount. That's how you do it. What's the solution to the given system of equations? Okay, we can use Desmos, of course. If I have time, I'm going to show you both ways. So first, we're going to do, I'm going to substitute. So 2y is equal to 5x. So I'm going to divide by 2. 5 over 2x is equal to y. Let's plug that in for y up here. So we got 5 over 2x minus 9x is equal to 13. Multiply everything by 2, just I don't want to deal with the fraction. 5x minus 18x equals 26. 5x minus 18x is negative 13x equals 26. Divide by negative 13. X is equal to negative 2. So it's got to be C, but we're going to double check. So negative 2 for x, negative 5 for y. Negative 2 for x, that's 18, negative 5 for y. It works in both cases. If I wanted to do it in Desmos, I'd write these functions in and look for the intersection point. I'm not going to do it because module 2, I'm always tight on time. I'll come back maybe. What is the range of the 7? Okay, range is the greatest value, which looks like 52, minus the smallest value, 23. So 52 minus 23 should be 29, and that's how you do it. You can double check with the calculator if you want. I'm just going to make sure I didn't see anything small. Yep, okay. To make sure 23 is the smallest. 2 customers purchase the same kind of bread and eggs, excuse me, at a store. The first customer paid $12.45 for, okay, hold on. There's a system of equations. First customer paid $12.45 for 1 loaf of bread and 2 dozen eggs. The second customer paid $19.42 for 4 loaves of bread. Obviously, X is the price of loaves of bread, and 1 dozen eggs. What's the cost in dollars of 1 dozen? So we're trying to solve for Y. That's the 1 dozen eggs. We got a system. I'm going to show you how to do it in Desmos this time. How about that? Because last time we did the system algebraically. Equals 12.45. 4x plus 1y equals 19.42. And we're going to look for that intersection point right here. And 1 dozen eggs is the y value, right? The cost of the loaf of bread is $3.77. Notice they have $3.77. That's to confuse you. And then there's the $4.34 for the dozen eggs. Let's make sure I got that right. Hold on. Make sure I didn't misread something. 1 loaf of bread, 2 dozen eggs, 4 loaves of bread, 1 dozen egg. Yep, that's how you do it. Done. 8, if the given equations are graphed in the XY plane, how many points of the graphs of the equations intersect? Well, let's graph it. Actually, wait. It's got to be, it's a 15, it's 0. I already can tell, but I'm going to show you. Because that is going down and its vertex is below y equals 18. That's why I can tell instantly. But let me show you how to do this otherwise in the calculator. Okay, So if we zoom out a little bit, you can see that they don't touch at all. And why did I know that? Because this is in vertex form. I knew the vertex is at 18, 15, and there's your vertex. And if that's the high, and it's negative, so that would be the highest point. And if this is at y is equal to 18, which is above that, it'll never touch. So 0 intersections, boom, done. A solution to the given system of equations is blah, blah. What is the greatest possible value of x? Okay, we're going to just do it in Desmos. Again, I could obviously do this algebraically, might arguably be faster. Let's just go here. X squared. I think this will be pretty quick. 16x plus 63. Okay. So we got a couple intersection points, and a solution given to was the greatest possible value of x. So this would be -9. That's not going to be the greatest. The greatest would be -6 right there. -6 is the winner. That would mean y is equal to 3, -6. I'm just double checking. Hold on, 36, 99, -96, and that's 3 again. Yep, that's how you do it. Boom, done. Okay. In the xy plane, line P has a slope of -5/3 and x-intercept of that. What is the... Okay, so we need the y-intercept. So let's create an equation for this line using point slope, because I have the slope as -5/3 and a point at -6, 0. So I'll do y minus y1, which is 0, equals -5/3 times x minus x1, which is -6. X minus -6 is x plus 6. That goes away because it's just 0. And then we're going to distribute y equals -5/3 x minus, because of the negative. And the -5/3 times 6, that's 2, 10, -10. Right? Because that becomes 30 over 3, -30 over 3, which is -10. And this is in slope-intercept form, meaning that is my y-intercept. So the y-coordinate, the y-intercept is -10. Notice, once again, you can have negative answers on the digital SAT for your response. You couldn't before, now you can. How many solutions, meaning for the old version of the SAT, how many solutions does this have? All right, let's distribute the 12. We got 12x minus 36 on the left-hand side equals -3x minus 36. Okay, I can already tell that the x coefficients are different, and it's a linear equation, so it's got to have one solution, exactly one. Now, we can solve for it. I can add 3x to the side, get 15x, add 36 to the other side equals 0. My solution is x equals 0, but that's how you do it. Done. 12. Kehlani used fabric measuring 5 yards in length to make each suit for a men's choir. The relationship between the number of suits and Kehlani made in total fabric proportion y is representing the equation y minus 9. Okay. Was it all right? We need an interpretation question. Hold on. Let me think about this for a second. Kehlani used measuring fabric 5 yards in length. So that's to make each suit. So that x is the number of suits. Hold on. So x. So I'll just do it like this. Y is equal to 5x plus 6. So x is the number of suits, right? And then times 5, and then 6 would be my y-intercept. So it's some starting value, and the total length of y. Okay, no, it's not 6 suits. No, it's not 6 yards total, because it depends on the number of suits. Yeah, it's this one. That's the 6 extra. It's the surplus. Okay, because you would need, let's say if you got 10 suits, you'd make 56, but you would only need 50. Right? You'd only need 50 yards, so that'd be 6 excess. It's weird. It's an interesting one, considering it's y-intercept. Usually y-intercept is the initial value. There was the surplus. Fascinating. Which quadratic equation has no real solutions? It's whichever one of these where the discriminant is negative. B squared minus 4ac. I can tell that this is going to be positive because minus 4ac, and that c is negative. It's going to all be positive. B squared minus 4ac. Hold on. 196, and then 4 times 49 is 160, 196. This is going to have a discriminant of 0. I'm doing it in my head. B squared minus 4ac that's going to be 0. For the right one, I'll actually show you why. Hold on. It's got to be b squared minus 4ac. B squared minus 4a. That's going to be, it's got to be d. It's got to be d. All right, now I'm going to show you why. So this is going to be, so a, b, and c. So b squared minus 4ac. It's got to be this one. So -14 squared is 196 positive, and then 4 times 5 is 20, times 49 is 980, right? 980, that's obviously going to be a negative number. When we have a negative discriminant, it's no real solutions. That's how you do it. Okay, the function f is defined by the given equation, blah, 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 is written as this, where p is a constant, which is defined as close to the value of p. Okay, interesting question, interesting question. Let's see. So that would be the 1 plus, that's 0.84. So we can separate that out as either 0.84 or 84 over 100, and then to the x over 4. But again, notice this little thing here. It's not to the x over 4, it's to the x, okay? And they didn't even have 84. That's nice of them, because sometimes they would have 84 just to trick you if you go fast on this. All right, so x over 4. Let's see how we can get this into x. Oh, we can do it like this. Let's see. If I did it over minus, it'd be 1.84. Let me think. And then it's times 1/4. Okay, I know how to do it. So never mind. I'm going to back up for a second. We're going to say like this. Before we convert it to that format, I'm going to say 1.84. That's to the 1/4 and then to the x. Now, the reason why I'm writing it like this is then this way we can break it up. I can simplify this, and then I got the x on the outside, and then I can do my thing. So let's do this in Desmos. What is 1.84? 1.84 to the 1/4 or 0.25. That is 1.16. Okay, so then we have 1.16 approximately to the x power, and then that would be 1 plus 16 over 100 approximately, right, to the x power, so it should be 16. Do they have 16? Yeah, they do. There we go. That's it. You can verify it multiple ways, right? You could also plug in an x here. You could plug in 16 here and plug in the same x, and if they give you the same value, then you know it's correct, okay? But I'm feeling pretty confident about that. We'll come back if we have time to verify that. Okay, 6 plus 7r has no solution. That means, wait a minute. Whoa, no solution with multiple variables. Okay, wait. We're going to have to do, this is interesting. Hold on. Okay, so let's simplify the bottom one. So I'm going to add 5w to the other side. This is very fascinating because this is a little different than what I've seen before. And then over here, we've got 7r is equal to pw minus 6. So the top equation I simplified there. The bottom one I simplified here. And then, so to substitute, right? Let's see if I'm doing this right. Pw minus 6 is equal to 10w plus 11. It's 10. It's got to be. Because look, I created it into an equation. It's almost like a linear equation via substitution. And if p is 10, this linear equation has no solution. Think about it. It's 10w minus 6 equals 10w plus 11. They're never going to be the same. So I think p would be 10 to get no solution. Now to verify this is a little trickier. But if we go back into this equation, let's see. 7r equals 10w minus 6. Yeah, no, it's right. Look, and then it's 7r equals 10w plus 11. It's just a linear equation with different slopes, which is exactly what we go for with no solutions for linear equations. All right, that's cool. Okay, next is number 16. Here we go. The graph y equals blah, blah, where b and c are constants. What is the value of b times c? Oh, interesting. Okay, so we have to figure out b and c in the quadratic. Okay, I know I'm going to do this. I'm going to use a little plug and chug. So we've got 0, -6 as one coordinate. We've also got a vertex at -1, -8. Okay, I know what we're going to do. We're going to use vertex form. Here, check this out. Y is equal to a times x minus -1 or plus 1 squared minus 8. And then we got to figure out what a is. And we can do that by plugging in that y-intercept. So then if I plug in 0 for x, that's a minus 8 equals -6. Add a to the other side. A is equal to 2. So then my function is y equals 2x plus 1 squared minus 8. And then if we simplify this, it's x plus 1, right? X plus 1. If we simplify this, that's x squared plus x, which is 2x plus 1. I'm just foiling it mentally. Times 2 minus 8. We got 2x squared plus 4x. And then that's plus 2 minus 8 is minus 6 is equal to y. So then, what is it? B times c. So b and c, which is -6. 4 times -6 is -24. Whew. We're going to double check it, make sure I didn't make any mistakes here. All I'm going to do is I'm going to check my different formatted equation. We should say it's the same equation, technically 4x minus 6. Just make sure that looks good. So we should have a y-intercept at 1 and -3. Yep. We have another y-intercept at -1, -8. Yeah. We are good to go. Boom, done. All right. 17. The graph of the linear function, boom, is shown if c and d are positive constants. Which equation could define f? Okay, well, what? Oh, it's super abstract. Okay, so this is it shifted up by 19. All right, well, let's just get the equation. I think that's the best way. Look, the slope is -4. It's going down by 4 over 1. So this equation is y equals -4x plus 3. But this is f of x plus 19. So to get to minus 19, we'd come back to f of x. So it's y equals -4x minus 16. Okay, so hold on, let's go back to this. So if c and d are positive constants, so what? Yeah, we need a minus in front of both. You see? Because it's got to be -4 for the slope in front of the x, so minus c, and then -16, so minus d, because it says c and d are positive. It's got to be a. Hold on, let me just see the rest of these. Yeah, that's the only thing that makes sense. This is plus 19. Is shown. Yeah, it's right. Okay. Boom, done. In the figure shown, AB, hold on, 18. In the figure shown, AB is 34. Okay, hold on. Let me do this so we can draw on it. Whoop. All right. AB is rad 34. AC is 3. And CE is 21. What is the area of AD? All right, so the big dog. Oh, proportionate triangles, right? So 3, here, watch this. We can figure out, what do we need to figure out, though? We need to figure out the area. Okay, so I need to figure out this side. So I'm going to use Pythagorean's theorem. 3 squared, which is 9, plus, we'll call this side x squared, is equal to rad 34 squared, which is 34, minus 9, x squared equals 34 minus 9 is 25, x equals 5. So this value in here is 5. 3, 5, rad 34, 9, 25, yeah. And then we can use proportionate triangles to find this side. So 3 over 5. So little leg over big leg is equal to little leg, which is 24, over, let's call it y. This would be y. And then let's cross multiply. We get 5 times 24 is 120 equals 3y. Divide by 3y equals 40. So this side equals 40. Now, to get the area of this triangle, it's a right triangle, we do base times height divided by 2. So 24 times 40 divided by 2, that becomes 20. 20 times 24, 48, 480. So 480 is the winner, I would say. 480 square units. Boom, boom, boom. I think we're good to go. All right. Woo, this one is. It's interesting. It's some of these questions are a little different than what I'm kind of traditionally seeing on these, so it's very interesting. The result of increasing the quantity x, okay. The result of increasing x by 400% is 60. So increasing is not multiplying by 4, okay? Increasing by 400% is saying we've got x, and then we're adding 400% of x, which is basically the decimal equivalent is 4. So x increased by 400% is 60. That's how they're going to get you. Because most people will probably choose 15. I think it's going to be 12. X plus 4x is 5x equals 60. X equals, divide by 5 is 12. Yep, that's it. 20. In the xy plane, circle has center C. Let's draw it out. Wait. Hold on. Wait. Before I draw anything out, let me read this. Has center L with HK. So x minus h plus, this is my traditional format, equals the radius squared. Points A and B lie in the circle. A has coordinates this. Oh boy. Ooh, this is interesting. Point A has that coordinate. What in the heck? Okay, this is insane. All right, this is really, really crazy. Let's see if I can get some idea here. Okay, we're going to draw an approximate graph. So we got a circle. Okay, we got a circle, points A and B. Point A has coordinates h plus 1 and ACB. Hold on, let's not even do it on the coordinate graph. So A, here, it's circle C, right? A, C, B is a right angle, so it's going through the center. Okay. And then it's saying this one is h plus 1, comma, k plus rad 102. Oh, so it's rad 102. Oh, so this is 1 to the right of the vertex and rad 102 above. Okay. Interesting. And then they want this length, which is the hypotenuse. Wait a minute. This should be doable. Hold on. So they want this length, which is AB. Hold on, there's a right triangle, and. Wait a minute. It's an isosceles right triangle because it is it's 2 radii and it's right triangle, so and then it's got to be 45, 90. Hold on. So then I can use Pythagorean's theorem. Watch this. So since this is the center at HK, I know how to do this now. I just have to get the formula down. So I can get the distance from here to here, and then use Pythagorean's theorem. So distance formula is the difference of the x's, so h plus 1 minus h, which is 1 squared, plus the difference of the y's. K plus rad 102 minus k, which is just going to be rad 102 squared, and then that's 1 plus 102 is 103. So the radius is the square root of 103, okay? And now use Pythagorean's theorem. This is also radius square root of 103. So Pythagorean's theorem is square root of 103 squared plus square root of 103 squared is equal to c squared. So that's 103 plus 103 is 206 is equal to c squared. Square root of that. C is equal to square root of 206. It's A. It's this one. Hold on. It's got to be. I think it's right. I'm going to roll with it. Wow, that was weird. Okay. Really good question, though. I loved it. For an electric field passing through a flat surface. Oh, what? Okay, through a flat surface perpendicular to it. Okay, for an electric field passing through a flat surface perpendicular to it. Flat surface electric field. The electric flux of the electric field through the surface is the product of the field's strength and the area. So strength and area is the flux. Okay. A certain flat surface consists of 2 adjacent squares. Oh my gosh. All right, these problems are tough. Okay, 2 adjacent squares, and where the side length in meters of the larger square, larger square. Hold on, let's make this bigger. I don't know exactly how. Where the side length of the meters of the larger square is 3 times the side length in meters of the smaller square. So we got x and 3x. Okay, an electric field with strength 20. Okay, hold on. So okay, got it. So we got to get area times the strength. Electric field with a strength of 29 volts per meter passes uniformly through this surface, which is perpendicular to the electric field. If the total electric flux is 4640, what is the electric flux in volts per meter through the larger square? Oh, okay, got it. So this is okay. I get it. So the area of the smaller square is, according to our formula, x squared. So we got to solve for x and then plug it back into this. I get it. It just seemed crazy. It's not as crazy as it looked. So first I'm going to divide both sides by 29, right, to isolate the x squared. So then x squared equals 160. Now, I'm not going to figure out x because this one has an area, since it's 3x by 3x, it's 9x squared. So I know the area is just 9 times 160, which is, I think, 1440. So then we've got the area is 1440, and we got the same strength. So 29 times 1440 will be the answer. 29. Okay, and we got 5 digits, and that is the max for what you can enter here. So I'm pretty sure that's right. Woo! All right. 8 minutes for the final question. Let's see how hard it is. I'm like, my heart's racing. Some of these questions are different than what I was expecting. This is very interesting. All right. The scatter plot shows a relationship between two variables, X and Y. For data set E, line of best fit is shown. Data set F is created by multiplying the Y coordinate of each data point from data set E. Okay, hold on. Data set F is created by multiplying the Y coordinate of each point by 3.9. All right. Wait, let me think about this for a second. All right. What's the best way to do this? Wait, it doesn't make sense. The scatter plot shows a relation between two variables. Right? A line of data set F is created by, multiplying the Y coordinate by 3.9. Got it. So it's a vertical stretch. It's a vertical stretch. Okay, which means I think the way that I'm going to do it, we could obviously plug and chug with each of these values and see which one is like look, I'm going to show you a couple different ways. First way I'm going to do it is I'm going to get an approximate line for this. So it's Y is equal to, I got a Y-intercept of, that looks like 12. I'm going to approximate. And then plus, what's my approximate slope? I'm going up from 12 to, let's say, 42.30, and then over by 20. So let's say 3/2 approximately, so 1.5x. Up by 30. Oh, no. Up by 30 over by 16. I'm sorry. 30 over 16. So that's about, let's say 30 over 16. That's fine. Okay. So here's my equation. Now, if I'm going to multiply every value by 3.9, I'm literally taking this and multiplying it by 3.9. So now let's approximate. Let's see here. 3.9 times 30 over 16. So the slope should be about 7.3 x plus 12 times 3.9. is 46.8. So we should have a y-intercept of 46.8, which we do. Oh, look at that. Right on the money. 46.8, 46.8. It's got to be one of these two, and a slope of 7.3. Ooh. I guess 5.9 is closer, but how did I get that so wrong? Hold on. Oh. I think my original slope was better. I just realized I made a mistake. So 12 up to, yeah, I did have it right before. 12 up to 42, that's 30, and then going across by 19? Okay, so it should be 30 over 19, not 16. Okay, let's try it again. 30 over 19. Much closer. It's not exact, but we got 6.15. Let's say 6.2. And what was their answer? 5.9. Yeah, I mean, that's pretty darn close. Okay, so that was my method where I basically got the line for this, and then I showed, multiplying every y value. You don't multiply the y. I don't know if people thought that, but you're multiplying the right-hand side of the equation because that translates to the y. Okay, now I'm going to show you another way to think about this. All we're going to do is we're going to plot a couple of points here that are on this line, and then I'm going to tell you what they should be in the right equation. We only need 2 points. So this one is 2, 15. And another good one, let's see, right here, 1840. So in the correct equation, we should get 2, 15 times 3.9, 45. Here, let me just do the calculator. 15, that should be 58.5. And 18, and then this should be times 40. Should give me 156. Okay, now let's say we're picking that first equation. We're going to check it. Y is equal to Okay, so we've got this equation, and then we're gonna see what happens when x equals 2 and when x equals 18. Okay, so let's see where it intersects our line. So does it intersect 58.6? 58.5, pretty darn close. And then the other point, it should be 156. Pretty darn close, 153, fine, right? Because we approximated. That's pretty good. Okay, so there's your double verification that this is the correct answer. All right, we got a little bit of time left, but not much. I'm just going to go ahead and close it. I'm going to submit it. If I made a mistake, we're going to check it now and go over that. I think I got everything right, but I don't know because there were some really tough questions. Maybe that rad 206 one. I don't know. That one, for some reason, seemed weird for some reason, but anyways, let's see now. Let's check the score. Okay, 1 second. We're going to go here. We're going to sign in. Boom. I hope you guys enjoyed that. Give me 1 second. I'm going to check the comments and questions. All right. Let's see here. All right, let's check it out. What did I get? Ah, shoot. I got something wrong. Okay, let me see what I got wrong here. Well, obviously I got all those wrong. Darn it. Which one did I get wrong? I'm feeling it's that rad 26. What? I was off by a factor of 10? What? How is that wrong? Wait a minute. 144. What did I do? Oh, I must have made a mistake. How was I off by a factor of 10? I can't believe it. What did I do? Okay, hold on. I have to go back to my... What did I do here? Hold on. Let me see if I can go back to that problem. Darn it. I thought I had it. I don't know what I did. What, did I write down something wrong? Okay, hold on. 4640 divided by 29. Okay, hold on. We're gonna check this out. Okay, so let's review it. I think, can I review it like this? Yeah, here we go. Oh, we have to go this way. All right, fine. Okay, let's go back to the question. Oh boy. All right, here we go. So let's review this one. Okay, so we're gonna put this up here. Okay, so I said strength of 29. So hold on. Flux electric field is the product of the electric field strength in the area of the surface, right? So the area is x squared. A certain flat surface can be 3 times larger. Electric field is 29. Okay, so 29 passes through the surface, which is perpendicular. So 29 times the area is 4640. Let me double check. I thought I did. Did I type that in wrong? 4640 divided by 29 is 160. That's what I got. So the area is 160. I'm kind of confused because if you get 160 and then I know that the area, this doesn't make sense. How can the flux be smaller? Wait, how can it be smaller when the area is larger? Hold on. The total. Oh, understand what they're saying. I get it. I get it. I get it. Now I understand what they're saying. They are saying the total is 4640 for both surfaces. So it would be, check it out, it'd be 29 times x squared plus 9x squared is equal to 4640. That's what the correct equation was. I missed that. I thought that was for the small one. So look, now you add that together, that becomes 10x squared. So it's 4640 divided by not 29, but 290. And then we get 16. We get x squared is equal to 16. Then plugging it back into the equation, we get the, let's say the flux. Flux is equal to 29 times, and then since we know x squared is 16, we just want the larger square. It's 9 times 16. So then it's 29 times 144, and that's 4176. Oh man, I thought I understood it, and then I almost did. It was just a slight reading mistake. Bummer. All right, but that was pretty cool. That was fun. So hope you guys enjoyed it. Let's talk about it. Chris Chica, hey, what's up, Chris? You're back. Can you make this a YouTube video? This is already gonna be a YouTube video, so it's gonna be out there for you to rewatch. Hope you can learn from my mistake. But anyways, I hope you guys enjoyed it. That's the fun of it. Sometimes I do make a mistake here and there, but that's what you guys have to go through. So I'm trying to replicate that experience as best I can for you. So I hope that was cool. I hope you guys enjoyed it. I gotta bounce, guys. I literally have a call in 1 minute, but thank you guys so much for joining. If you did like this video, make sure to click that like button. If you want the best resource for digital SAT prep out there with my video explanations out there as well, it's included in the purchase. Check out the SATcrashcourse.com. You can see it on the top banner. Use the code SCALAR, all caps, SCALAR, for a 20% discount. I highly recommend it. Like I said, my video explanations are up there. Spent a lot of time putting those together, and I think they're really powerful. And if you haven't liked this video yet and you did enjoy it and you found it useful, please click that like button. It tremendously helps out the algorithm when you do so. And last but not least, if you want to click subscribe, make sure to do that so I can see you in the next video. All right, guys, thank you so much, and I'll see you next time. Take it easy.